Welcome to Loops and Loops, your guide to the revolutionary world of blockchain technology. Blockchain has disrupted traditional systems by offering secure, transparent, and decentralized solutions to a wide array of industries. Join us as we embark on an insightful journey through the realm of blockchain, exploring its foundational principles, innovative applications, and transformative potential. Whether you're a blockchain enthusiast, a curious learner, or simply interested in the future of digital transactions, you're in for an enlightening experience. So tighten your loops, unlock the power of decentralized networks, and let's delve into the captivating world of blockchain together. Blockchain technology is a decentralized digital ledger that records transactions across multiple computers in a way that is secure, transparent, and tamper-resistant. Unlike traditional databases, which are centralized and controlled by a single entity, blockchain operates on a peer-to-peer network where each participant has a copy of the entire ledgers. Decentralized networks in blockchain refer to the distributed nature of the technology, where data is stored and verified by multiple nodes rather than being controlled by a single authority. This decentralization enhances security and resilience, as there is no single point of failure in the network. Key components of a blockchain system include blocks, which contain batches of transactions, cryptographic hashes, which ensure the integrity of each block, and consensus mechanisms, which enable nodes to agree on the validity of transactions and maintain a consistent ledger. Blockchain ensures data integrity and security through cryptographic techniques such as hashing and digital signatures. Hashing creates unique fingerprints for each block of data, making it virtually impossible to alter without detection. Digital signatures verify the authenticity and integrity of transactions, ensuring that only authorized parties can make changes to the blockchain. Consensus mechanisms in blockchain networks are protocols that enable nodes to agree on the validity of transactions and reach consensus on the state of the ledger. Examples of consensus mechanisms include proof of work, proof of stake, and delegated proof of stake, each with its own method for validating transactions and adding them to the blockchain. Smart contracts are self-executing contracts with the terms of the agreement directly written into code. They automate and enforce the execution of agreements without the need for intermediaries, reducing the risk of fraud and streamlining business processes. Smart contracts play a key role in blockchain by enabling trustless and transparent execution of transactions. Using blockchain for data management offers several advantages, including enhanced security, transparency, and efficiency. Because data is distributed across multiple nodes in the network, it is resistant to tampering and censorship. Additionally, blockchain provides a transparent and audible record of transactions, reducing the risk of fraud and errors. Blockchain enables transparency and immutability of data by storing transactions in a chronological chain of blocks that cannot be altered or deleted. Once a transaction is recorded on the blockchain, it is cryptographically linked to previous blocks, creating an immutable record of data that is transparent and audible by all participants. Adding transactions to a blockchain involves several steps, including creating a new block, verifying the validity of transactions, and reaching consensus with other nodes in the network. Once a block is validated and added to the blockchain, it becomes a permanent part of the ledger and cannot be altered or removed. Blockchain handles transaction verification and validation through consensus mechanisms, which enable nodes in the network to agree on the validity of transactions and maintain a consistent ledger. Transactions are verified by network participants using cryptographic techniques, and consensus is reached through a combination of incentives and protocols. Examples of blockchain applications beyond cryptocurrencies include supply chain management, digital identity verification, voting systems, and decentralized finance platforms. These applications leverage blockchain's decentralized and tamper-resistant nature to enhance security, transparency, and efficiency in various industries. Blockchain ensures trust in peer-to-peer transactions by providing a transparent and tamper-resistant record of data that is auditable by all participants. Because transactions are verified and recorded on a decentralized ledger, there is no need for trust in a central authority or intermediary. Public blockchains are open and permissionless, allowing anyone to join the network, participate in transaction validation, and access the ledger. Private blockchains, on the other hand, are permissioned and restricted to authorized participants, providing greater control over access and governance. Cryptocurrency is a digital or virtual form of currency that utilizes cryptography for security and operates independently of a central authority, such as a government or bank. The first and most well-known cryptocurrency is Bitcoin, which was introduced in 2009 by an anonymous person or group using the pseudonym Satoshi Nakamoto. Since then, thousands of other cryptocurrencies, often referred to as altcoins, have been created, each with its unique features and purposes. At the core of cryptocurrencies is the blockchain technology, which serves as a decentralized public ledger that records all transactions across a network of computers. Each transaction is verified by network nodes through cryptographic techniques, ensuring transparency and security. Once verified, transactions are added to a block, which is then linked to the previous blocks in a chronological chain, hence the name blockchain. The adoption of cryptocurrencies has grown significantly over the years, with increasing acceptance by merchants, institutions, and individuals worldwide. Major companies such as Tesla, PayPal, and Microsoft now accept Bitcoin as a form of payment, signaling a shift towards mainstream adoption. Additionally, institutional investors and hedge funds are increasingly allocating capital to cryptocurrencies as part of their investment portfolios, further legitimizing the asset class. However, cryptocurrencies also face challenges and criticisms, including regulatory uncertainty, price volatility, security concerns, and environmental impact. Regulatory bodies around the world are grappling with how to regulate cryptocurrencies effectively to prevent fraud, money laundering, and other illicit activities while fostering innovation and protecting investors. Despite these challenges, the underlying technology of cryptocurrencies, blockchain, continues to evolve and find applications beyond finance, including supply chain management, healthcare, voting systems, and decentralized finance. The growing interest and investment in cryptocurrencies and blockchain technology suggests that they may play a significant role in shaping the future of finance and technology. Distributed ledger. Technology in blockchain systems plays a crucial role in maintaining a decentralized and transparent record of transactions. Instead of relying on a central authority to validate and store data, blockchain uses a distributed ledger that is replicated across multiple nodes in a network. This distributed nature enhances security and resilience, as there is no single point of failure or control. Blockchain enables traceability and provenance of assets by recording each transaction in a chronological chain of blocks. Each block contains a timestamp and a reference to the previous block, creating an immutable and transparent record of asset ownership and transaction history. This feature is particularly useful in supply chain management, where it allows stakeholders to track the movement of goods from production to delivery. Mining in blockchain networks refers to the process of validating and adding transactions to the blockchain through computational work. Miners compete to solve complex mathematical puzzles, with the first miner to solve the puzzle earning the right to add a new block of transactions to the blockchain. This process not only secures the network, but also incentivizes miners to participate in the validation process. Blockchain has numerous potential use cases in supply chain management, including tracking the provenance of goods, streamlining logistics processes, and reducing counterfeiting and fraud. By recording each step of the supply chain on a transparent and immutable ledger, blockchain enhances transparency, traceability, and accountability throughout the supply chain. Blockchain impacts financial transactions and remittances by providing a secure, transparent, and efficient platform for transferring value. Unlike traditional banking systems, which rely on intermediaries to facilitate transactions, blockchain enables peer-to-peer transactions without the need for intermediaries. This reduces costs, delays, and the risk of fraud associated with traditional financial transactions. Tokenization in blockchain refers to the process of representing real-world assets or rights on a blockchain in the form of digital tokens. These tokens can represent anything of value, such as currencies, securities, commodities, or property rights. By tokenizing assets, blockchain enables fractional ownership, enhanced liquidity, and more efficient trading of assets on decentralized platforms. Scalability is a significant challenge in blockchain networks, as increasing transaction volumes can lead to congestion and slower transaction processing times. This challenge arises from the inherent trade-off between decentralization, security, and scalability in blockchain systems. As blockchain networks grow in size and usage, addressing scalability becomes increasingly important to ensure the continued efficiency and viability of the network. Blockchain ensures data privacy and confidentiality through cryptographic techniques such as encryption and zero-knowledge proofs. By encrypting transaction data and ensuring that only authorized parties have access to sensitive information, blockchain protects the privacy of users and maintains the confidentiality of transaction details. Permissioned blockchains require participants to obtain permission from a central authority or network administrator before they can join the network and participate in transaction validation. Permissionless blockchains, on the other hand, are open and decentralized, allowing anyone to join the network and participate in transaction validation without permission. Each type of blockchain has its own advantages and use cases depending on the desired level of control and decentralization. Consensus algorithms play a crucial role in maintaining the integrity of blockchain by ensuring that all nodes in the network agree on the validity of transactions and the state of the ledger. These algorithms enable decentralized networks to reach consensus and prevent malicious actors from tampering with the blockchain. Examples of consensus algorithms include proof of work, proof of stake, and practical Byzantine fault tolerance. Blockchain enables peer-to-peer energy trading in the energy sector by allowing consumers to buy and sell excess energy directly with each other without the need for intermediaries. This decentralized approach to energy trading enhances efficiency, reduces costs, and promotes renewable energy adoption by enabling consumers to monetize their excess energy production. Blockchain interoperability refers to the ability of different blockchain networks to communicate and share data with each other seamlessly. Interoperability is essential for enabling cross-chain transactions, facilitating the exchange of assets and data between different blockchain platforms, and promoting the adoption of decentralized applications across multiple networks. Regulatory challenges facing the adoption of blockchain technology include uncertainty about legal frameworks, compliance with existing regulations, and concerns about consumer protection and investor security. Regulators around the world are grappling with how to regulate blockchain-based applications and cryptocurrencies while balancing innovation and risk mitigation. Blockchain impacts the insurance industry and claims processing by providing a secure, transparent, and immutable platform for recording insurance policies and processing claims by digitizing and automating insurance processes on the blockchain. Insurers can reduce costs, streamline claims processing, and enhance transparency and trust in the insurance ecosystem. Digital identity management using blockchain involves using blockchain technology to securely store and manage digital identities, enabling individuals to control and share their personal information securely and transparently. Blockchain-based digital identity solutions offer greater privacy, security, and control over personal data, reducing the risk of identity theft, fraud, and data breaches. The environmental implications of blockchain mining are significant due to the energy-intensive nature of the process. Mining involves solving complex mathematical puzzles to validate transactions and add them to the blockchain ledger. This process requires a substantial amount of computational power, leading to high energy consumption and carbon emissions. As a result, blockchain mining has raised concerns about its environmental impact, particularly regarding electricity consumption and carbon footprint. Blockchain enables voting systems and secure elections by providing a transparent, tamper-proof, and decentralized platform for recording and verifying votes. By using blockchain technology, voting systems can enhance transparency, integrity, and security in electoral processes. Each vote is recorded on a blockchain ledger, making it immutable and transparent, while cryptographic techniques ensure the authenticity and integrity of the voting data. This enables secure and verifiable elections, reduces the risk of fraud and manipulation, and enhances trust in the electoral process. Non-fungible tokens, also called as NFTs, are unique digital assets that represent ownership or proof of authenticity of a specific item or piece of content. Unlike cryptocurrencies such as Bitcoin or Ethereum, which are fungible and can be exchanged on a one-to-one basis, NFTs are indivisible and cannot be exchanged or replicated. NFTs have various use cases, including digital art, collectibles, gaming assets, and intellectual property rights. They enable creators to tokenize and monetize their digital creations, while collectors can buy, sell, and trade unique digital assets securely on blockchain platforms. Blockchain plays a crucial role in combating counterfeit products by providing a transparent and immutable record of product provenance and authenticity. By recording each step of the supply chain on a blockchain ledger, manufacturers, retailers, and consumers can track the movement of goods from production to delivery. This enhances transparency, traceability, and accountability throughout the supply chain, making it more difficult for counterfeiters to introduce fake or unauthorized products into the market. Blockchain impacts the real estate industry and property transactions by streamlining and automating processes such as title transfers, property sales, and lease agreements. By recording property ownership and transaction details on a blockchain ledger, real estate transactions become more efficient, transparent, and secure. Blockchain technology enables peer-to-peer property transactions, reduces the need for intermediaries, and minimizes the risk of fraud and disputes. Decentralized finance refers to a set of financial services and applications built on blockchain technology, aiming to democratize access to financial products and services, such as lending, borrowing, trading, and asset management. DeFi platforms operate without intermediaries, such as banks or financial institutions, allowing users to interact directly with decentralized protocols and smart contracts. DeFi offers various applications, including decentralized exchanges, liquidity pools, yield farming, and stablecoins, enabling users to access financial services in a permissionless and transparent manner. Energy efficiency considerations in blockchain mining are essential due to the significant energy consumption associated with the process. To address this issue, researchers and developers are exploring alternative consensus mechanisms and mining algorithms that require less energy. Additionally, initiatives such as renewable energy-powered mining farms and energy-efficient hardware aim to reduce the environmental impact of blockchain mining while maintaining network security and decentralization. Blockchain enables cross-border payments and remittances by providing a fast, secure, and cost-effective platform for transferring value across borders. Traditional cross-border payment systems are often slow, expensive, and inefficient due to multiple intermediaries, currency conversion fees, and regulatory constraints. Blockchain technology eliminates intermediaries and enables peer-to-peer transactions, reducing costs, delays, and friction in cross-border payments and remittances. Blockchain-based digital asset management involves using blockchain technology to securely store, transfer, and manage digital assets such as cryptocurrencies, tokens, and NFTs. Blockchain provides a transparent and immutable ledger for recording ownership and transaction details of digital assets, enhancing security, transparency, and trust. Digital asset management platforms built on blockchain enable users to securely custody, transfer, and trade digital assets while maintaining control and ownership of their assets. Blockchain technology plays a crucial role in protecting intellectual property rights by providing a transparent and immutable record of ownership and provenance. By recording intellectual property rights on a blockchain ledger, creators can prove ownership, establish a chain of custody, and enforce copyright protection. Blockchain-based platforms offer various solutions for managing and licensing intellectual property, such as digital rights management, content monetization, and royalty tracking, enabling creators to protect and monetize their intellectual assets more effectively. Blockchain ensures data integrity in healthcare records by providing a secure and tamper-proof platform for storing and sharing patient data. By recording healthcare transactions and patient information on a blockchain ledger, healthcare providers can maintain a transparent and immutable record of patient health records, prescriptions, treatments, and medical histories. This enhances data security, privacy, and interoperability while reducing the risk of data breaches, fraud, and unauthorized access to patient information. Regulatory compliance in blockchain involves ensuring that blockchain-based applications and transactions comply with relevant laws, regulations, and industry standards. This includes regulations related to data privacy, consumer protection, anti-money laundering, know your customer requirements, securities regulations, and tax compliance. Regulatory challenges include uncertainty about legal frameworks, compliance with existing regulations, and concerns about consumer protection and investor security. Regulators around the world are grappling with how to regulate blockchain-based applications and cryptocurrencies while balancing innovation and risk mitigation. Blockchain impacts digital voting systems and electoral processes by providing a secure, transparent, and tamper-proof platform for recording and verifying votes. By using blockchain technology, voting systems can enhance transparency, integrity, and security in electoral processes. Each vote is recorded on a blockchain ledger, making it immutable and transparent, while cryptographic techniques ensure the authenticity and integrity of the voting data. This enables secure and verifiable elections, reduces the risk of fraud and manipulation, and enhances trust in the electoral process. Tokenization of real-world assets involves representing physical assets, such as real estate, art, commodities, or securities, as digital tokens on a blockchain ledger. By tokenizing assets, blockchain enables fractional ownership, enhanced liquidity, and more efficient trading of assets on decentralized platforms. Tokenization allows investors to access previously illiquid assets, diversify their portfolios, and participate in new investment opportunities. Additionally, tokenization enables asset owners to unlock value from their assets, increase liquidity, and broaden their investor base. Blockchain plays a crucial role in ensuring transparency in charity donations by providing a secure and immutable ledger for recording donation transactions. Each donation made to a charity organization is recorded on a blockchain, enabling donors to verify the authenticity and transparency of the donation process. By using blockchain technology, charity organizations can enhance trust and accountability, as donors can track how their donations are used and ensure that they reach their intended beneficiaries. This transparency helps prevent fraud, mismanagement, and corruption in the charity sector, fostering greater confidence among donors and promoting accountability. Blockchain enables secure and transparent land registry systems by recording property ownership and transaction details on a tamper-proof and decentralized ledger. Traditional land registry systems are often prone to corruption, fraud, and disputes due to manual record keeping and centralized control. By using blockchain technology, land registry systems become more efficient, transparent, and secure, as each property transaction is recorded on a blockchain ledger, making it immutable and verifiable. This enhances transparency, reduces the risk of fraud, and improves the integrity of land ownership records, thereby facilitating smoother property transactions and reducing legal disputes. Blockchain-based identity verification involves using blockchain technology to securely and transparently verify and authenticate individual identities. By recording identity information on a blockchain ledger, individuals can maintain control over their personal data while providing proof of identity to third parties. Blockchain enables secure and tamper-proof identity verification processes, reducing the risk of identity theft, fraud, and unauthorized access to personal information. This enhances privacy, security, and trust in identity verification systems, enabling individuals to access services and participate in digital transactions more securely. Scalability solutions being explored for blockchain networks include various techniques and technologies aimed at increasing the throughput and capacity of blockchain systems to handle a larger number of transactions. Some scalability solutions include sharding, which involves partitioning the blockchain network into smaller subsets called shards to process transactions in parallel. Off-chain scaling solutions such as sidechains and payment channels, which enable transactions to be conducted off the main blockchain to alleviate congestion and reduce fees. And Layer 2 scaling solutions such as state channels and plasma, which enable faster and cheaper transactions by processing them outside the main blockchain. Blockchain enables secure and transparent food traceability. By recording the journey of food products from farm to table on a tamper-proof and decentralized ledger. By using blockchain technology, food producers, distributors, and retailers can track and trace the movement of food products throughout the supply chain, recording key information such as origin, production, handling, and storage conditions. This enhances transparency, accountability, and trust in the food supply chain, enabling consumers to verify the authenticity, quality, and safety of food products, while also helping to prevent food fraud, contamination, and supply chain disruptions. Blockchain-based decentralized autonomous organizations are organizations governed by smart contracts and operated by a community of stakeholders without the need for centralized management or control. Decentralized autonomous organizations use blockchain technology to automate decision-making processes, manage resources, and execute operations transparently and autonomously. Participants in a decentralized autonomous organization can vote on proposals, allocate funds, and participate in governance activities using tokens or voting rights recorded on a blockchain ledger. This enables decentralized and democratic governance of organizations, fostering transparency, trust, and collaboration among stakeholders. Blockchain technology plays a significant role in the gaming industry by enabling secure and transparent ownership, trading, and monetization of in-game assets. By recording digital assets such as virtual currencies, items, and tokens on a blockchain ledger, players can securely buy, sell, and trade in-game assets without the need for intermediaries. Blockchain also enables the creation of provably fair games and decentralized gaming platforms, where game rules and outcomes are transparently recorded on a blockchain, ensuring fairness and integrity. Additionally, blockchain-based gaming ecosystems incentivize player engagement and participation through token rewards and incentives, fostering a vibrant and decentralized gaming economy. Privacy considerations in blockchain-based systems include protecting sensitive information, such as personal data and transaction details, from unauthorized access, disclosure, and misuse. While blockchain technology provides transparency and immutability, it also raises privacy concerns due to the public and permanent nature of blockchain ledgers. To address these concerns, developers and researchers are exploring privacy-enhancing techniques such as zero-knowledge proofs, homomorphic encryption, and confidential transactions, which enable users to transact privately on a blockchain without revealing sensitive information. These privacy-enhancing technologies help preserve the confidentiality and anonymity of users while maintaining the integrity and security of blockchain transactions. Blockchain impacts digital asset management and tokenization by enabling the representation and transfer of real-world assets as digital tokens on a blockchain ledger. By tokenizing assets such as real estate, art, securities, and commodities, blockchain enables fractional ownership, enhanced liquidity, and more efficient trading of assets on decentralized platforms. Tokenization democratizes access to investment opportunities, unlocks liquidity in traditionally illiquid markets, and reduces barriers to entry for investors. Additionally, blockchain-based digital asset management platforms facilitate the issuance, transfer, and management of digital assets in a secure, transparent, and compliant manner, enabling users to tokenize, trade, and invest in a wide range of assets. Blockchain-based credential verification involves using blockchain technology to securely and transparently verify and authenticate credentials such as academic degrees, professional certifications, and licenses. By recording credential information on a blockchain ledger, individuals can maintain control over their credentials while providing proof of their qualifications to employers, educational institutions, and other third parties. Blockchain ensures the authenticity, integrity, and immutability of credential records, reducing the risk of credential fraud, forgery, and misrepresentation. This enhances trust, efficiency, and transparency in credential verification processes, enabling faster and more reliable verification of qualifications. Blockchain plays a crucial role in securing Internet of Things devices by providing a decentralized and tamper-proof platform for recording and verifying device identity, ownership, and transactions. By using blockchain technology, IoT devices can securely communicate and transact with each other without the need for centralized intermediaries. Blockchain enables secure device provisioning, authentication, and access control, ensuring that only authorized devices can interact with each other and access sensitive data and resources. Additionally, blockchain enhances the integrity and transparency of IoT data by recording device-generated data on a tamper-proof ledger, enabling stakeholders to verify the authenticity and integrity of IoT data. Blockchain-based digital identity solutions involve using blockchain technology to securely and transparently manage and verify digital identities. Instead of relying on centralized authorities to authenticate identity credentials, blockchain enables individuals to control and manage their own digital identities through decentralized and tamper-proof identity systems. By recording identity information on a blockchain ledger, individuals can maintain ownership of their personal data and selectively disclose identity attributes as needed, enhancing privacy, security, and trust in digital identity verification processes. Challenges associated with data storage and retrieval in blockchain include scalability, latency, and cost. As blockchain ledgers grow in size with each transaction added, storing and retrieving large volumes of data becomes increasingly challenging and resource-intensive. Scalability solutions such as sharding, off-chain storage, and Layer 2 scaling technologies are being explored to address these challenges and improve the efficiency of data storage and retrieval in blockchain networks. Blockchain impacts the music industry and royalty payments by enabling transparent and efficient royalty distribution mechanisms. By recording music ownership rights and royalty agreements on a blockchain ledger, artists, songwriters, and music publishers can receive fair and timely compensation for their creative works. Blockchain also enables transparent tracking and tracing of music usage and royalties, reducing disputes, intermediaries, and administrative overhead in the music licensing and royalty payment process. Blockchain-based content authentication involves using blockchain technology to verify the authenticity and integrity of digital content such as images, videos, and documents. By recording content metadata and cryptographic hashes on a blockchain ledger, content creators and consumers can verify the originality and provenance of digital content, reducing the risk of content manipulation, piracy, and forgery. Blockchain-based content authentication solutions enhance trust, transparency, and accountability in digital content distribution and consumption. Blockchain technology plays a vital role in ensuring fair trade and ethical sourcing by providing transparent and immutable records of product provenance and supply chain transactions. By recording product origin, production, and distribution details on a blockchain ledger, consumers and businesses can verify the authenticity, quality, and ethical sourcing practices of products, such as fair trade coffee, conflict-free diamonds, and sustainable seafood. Blockchain-based supply chain solutions promote transparency, accountability, and sustainability in global trade and supply chains. Blockchain enables secure and transparent document verification. By recording document metadata and cryptographic hashes on a blockchain ledger. By using blockchain technology, organizations can securely verify the authenticity and integrity of digital documents, such as contracts, certificates, and license, without relying on centralized authorities or intermediaries. Blockchain-based document verification solutions enhance trust, security, and efficiency in document management and authentication processes. The concept of blockchain-based tokenized securities involves representing traditional financial assets such as stocks, bonds, and derivatives as digital tokens on a blockchain ledger. By tokenizing securities, blockchain enables fractional ownership, enhanced liquidity, and more efficient trading of financial assets on decentralized platforms. Blockchain-based tokenized securities democratize access to investment opportunities, reduce settlement times, and enhance transparency and compliance in financial markets. Interoperability between blockchain networks refers to the ability of different blockchain platforms to communicate, share data, and transact with each other seamlessly. Challenges associated with interoperability include differences in blockchain protocols, consensus mechanisms, and data formats, which can hinder interoperability and data exchange between blockchain networks. Interoperability solutions such as cross-chain communication protocols, interoperability standards, and blockchain bridges are being developed to address these challenges and enable seamless interoperability between blockchain networks. Blockchain impacts the art market and provenance verification by providing transparent and immutable records of artwork ownership and transaction history, by recording art provenance, ownership rights, and sales transactions on a blockchain ledger. Artists, collectors, and art dealers can verify the authenticity and provenance of artworks, reducing the risk of art fraud, forgery, and theft. Blockchain-based provenance solutions enhance trust, transparency, and confidence in the art market, enabling smoother transactions and reducing disputes. Blockchain-based decentralized exchanges are cryptocurrency trading platforms that operate without centralized intermediaries or custodians. Instead of relying on centralized order matching and settlement systems, decentralized exchanges use smart contracts and decentralized protocols to facilitate peer-to-peer trading of digital assets directly between users. By using blockchain technology, decentralized exchanges enhance security, privacy, and censorship resistance in cryptocurrency trading, while also promoting transparency and decentralization in financial markets. Blockchain secures digital healthcare records by providing a tamper-proof and transparent platform for recording and managing patient health data. By using blockchain technology, healthcare providers can securely store and share electronic health records, medical history, and treatment data, while ensuring patient privacy and data security. Blockchain-based healthcare record systems empower patients to control access to their health information, enhance interoperability between healthcare providers, and streamline data exchange and consent management processes. Blockchain enables secure and transparent carbon footprint, tracking by recording and verifying carbon emissions data on a blockchain ledger. By using blockchain technology, companies, governments, and organizations can track and trace carbon emissions throughout the supply chain, recording emissions data from production to consumption. Blockchain-based carbon footprint tracking solutions enhance transparency, accountability, and credibility in carbon accounting and emissions reporting, enabling more accurate measurement, reduction, and offsetting of carbon emissions. Challenges associated with blockchain governance and consensus include reaching consensus among network participants, managing conflicts of interest, and ensuring compliance with regulatory requirements. As blockchain networks grow and evolve, governance structures and decision-making processes become more complex and challenging to manage. Solutions such as governance frameworks, voting mechanism, and consensus algorithms are being explored to address these challenges and promote effective governance and consensus in blockchain networks. Blockchain impacts the luxury goods industry and anti-counterfeiting by providing transparent and immutable records of product provenance and authenticity. By recording product ownership, manufacturing, and distribution details on a blockchain ledger, luxury brands and consumers can verify the authenticity and integrity of luxury goods, reducing the risk of counterfeiting, fraud, and brand dilution. Blockchain-based anti-counterfeiting solutions enhance trust, brand reputation, and consumer confidence in luxury goods, enabling smoother transactions and stronger brand loyalty. Blockchain-based decentralized social networks are social media platforms that operate on blockchain technology, offering users greater control over their data, privacy, and content. Instead of relying on centralized servers and data repositories, decentralized social networks use blockchain technology to store and manage user data and interactions in a distributed and censorship-resistant manner. By using blockchain, decentralized social networks enhance user privacy, data ownership, and freedom of expression, while also promoting transparency and accountability in social media platforms. Blockchain plays a crucial role in ensuring data integrity in research and academia by providing a tamper-proof and transparent platform for recording research findings, scholarly publications, and academic credentials. By using blockchain technology, researchers, publishers, and academic institutions can securely timestamp and verify the authenticity of research data and publications, reducing the risk of data manipulation, plagiarism, and academic misconduct. Blockchain-based academic record systems enhance transparency, trust, and accountability in academic research and credentialing processes, promoting integrity and reliability in scholarly communication. Blockchain enables secure and transparent diamond certification by recording diamond ownership, provenance, and certification details on a blockchain ledger. By using blockchain technology, diamond industry, participants can track and verify the authenticity and ethical sourcing of diamonds, reducing the risk of counterfeit diamonds, conflict diamonds, and supply chain fraud. Blockchain-based diamond certification systems enhance trust, transparency, and sustainability in the diamond industry, enabling consumers to make more informed and ethical purchasing decisions. The concept of blockchain-based digital collectibles involves using blockchain technology to tokenize and authenticate digital assets such as artwork, trading cards, and virtual items. By representing digital collectibles as non-fungible tokens on a blockchain ledger, creators and collectors can verify the uniqueness, ownership, and provenance of digital assets, enabling secure and transparent trading and ownership transfer. Blockchain-based digital collectibles enhance scarcity, authenticity, and value in the digital collectibles market, opening up new opportunities for creators and collectors alike. Challenges associated with blockchain scalability and transaction speed include limitations in blockchain throughput, block size, and consensus mechanisms which can hinder the scalability and performance of blockchain networks. As blockchain adoption grows and transaction volumes increase, scalability solutions such as sharding, layer 2 scaling, and consensus algorithm optimizations are being explored to address these challenges and improve the scalability and efficiency of blockchain networks. Blockchain impacts the pharmaceutical industry and drug traceability by providing transparent and immutable records of drug manufacturing, distribution, and supply chain transactions. By recording pharmaceutical supply chain data on a blockchain ledger, pharmaceutical companies, regulators, and consumers can track and verify the authenticity, safety, and efficacy of drugs, reducing the risk of counterfeit drugs, medication errors, and supply chain disruptions. Blockchain-based drug traceability systems enhance patient safety, regulatory compliance, and supply chain integrity in the pharmaceutical industry. Blockchain-based secure messaging platforms use blockchain technology to encrypt and authenticate messages, ensuring confidentiality, integrity, and privacy in communication. By leveraging blockchain's cryptographic features and decentralized architecture, secure messaging platforms enable end-to-end encryption, message authentication, and tamper-proof message storage, reducing the risk of data breaches, surveillance, and unauthorized access. Blockchain-based secure messaging platforms enhance privacy, security, and trust in digital communication, empowering users to communicate securely without intermediaries or third-party surveillance. Blockchain plays a crucial role in securing digital rights management by providing transparent and immutable records of digital content ownership, usage rights, and licensing agreements. By recording digital rights on a blockchain ledger, content creators, distributors, and consumers can manage and enforce copyright protection, content licensing, and royalty distribution in a decentralized and transparent manner. Blockchain-based DRAM solutions enhance copyright enforcement, content monetization, and intellectual property protection in the digital age. Blockchain enables secure and transparent carbon offset, tracking by recording carbon offset credits, emissions reductions, and environmental impact data on a blockchain ledger. By using blockchain technology, organizations, governments, and individuals can track and verify the authenticity and impact of carbon offset projects, reducing the risk of double counting, fraud, and greenwashing. Blockchain-based carbon offset tracking solutions enhance transparency, accountability, and credibility in carbon offset markets, facilitating more effective climate action and carbon mitigation efforts. Blockchain impacts the legal industry and contract management by providing transparent and immutable records of legal agreements, contracts, and transactions. By using blockchain technology, legal professionals, businesses, and individuals can create, execute, and enforce smart contracts and digital agreements in a decentralized and tamper-proof manner. Blockchain-based contract management systems enhance transparency, automation, and efficiency in legal processes, reducing the risk of contract disputes, fraud, and inefficiencies in the legal industry. The concept of blockchain-based decentralized marketplaces involves using blockchain technology to create peer-to-peer trading platforms for digital assets, goods, and services. By leveraging smart contracts and decentralized protocols, decentralized marketplaces enable direct trading, secure transactions, and automated escrow services without intermediaries or centralized authorities. Blockchain-based decentralized marketplaces promote peer-to-peer commerce, reduce transaction costs, and enhance privacy and censorship resistance in online marketplaces. Blockchain impacts the advertising industry and digital ad verification by providing transparent and audible records of ad impressions, clicks, and conversions on a blockchain ledger. By using blockchain technology, advertisers, publishers, and ad networks can verify the authenticity and effectiveness of digital advertising campaigns, reducing the risk of ad fraud, bot traffic, and then misplacement. Blockchain-based verification platforms enhance transparency, accountability, and trust in digital advertising, enabling advertisers to optimize ad spend and improve campaign performance. An analogy with Google Sheets on Google Drive is used to elucidate the functioning of blockchain. Similar to how Google Sheets is shared among multiple users over a network, blockchain comprises a shared ledger accessible to all nodes in the network. Any modifications made to the ledger are instantly updated across all copies on the network, ensuring real-time synchronization. The consensus mechanism in blockchain requires agreement among participating nodes before validating transactions, preventing issues such as double spending. This consensus mechanism ensures that only verified transactions are added to the blockchain ledger, maintaining the integrity of the digital currency system. As we conclude today's exploration of blockchain, we hope you're inspired to further explore the transformative potential of this groundbreaking technology. Don't forget to subscribe to Loops and Loops for more captivating content on blockchain, cryptocurrency, and emerging trends. Let's continue to loop in new knowledge, innovate with decentralized solutions, and shape a future empowered by blockchain technology. Until next time, keep those loops tight, keep exploring, and keep embracing the transformative power of blockchain. Thank you for joining us on this enlightening journey.